and welcome back to IQ Robot Games Camp. My name is Audra and I am one of your Vex Camp counselors, and I can't wait to start driving my Clawbot with you in today's session. So after the last session, you added on to your BaseBot to build your very own Clawbot. And so in this session, we are going to learn all about how to control that Clawbot so we can move things around so that you can participate in the Relay Race Challenge. By the end of this session, you are going to know how to drive your Clawbot so well that you can pick up all kinds of different household objects and move them from one side of the race space to the other as fast as possible. So in order for us to get started, there's just a few materials that we're going to need for our session. You are going to need your fully built Clawbot that you built after the last session, as well as your charged IQ battery, your charged IQ controller, and your IQ kit. In addition to those things, we're going to need a few different household items that we can use in the Relay Race Challenge. Things like a soda can or an empty cup or a tissue box, a baseball. You also might want to have some string or tape that you can use to mark your relay race starting and finishing points. Now, before we dive in, just a quick reminder that at any point in time, you can pause the video if you need to gather your materials or go back and rewind and replay something so that you can see what we did another time or hear what we were talking about one more time. You can do that. So you can stop the video at any point to get what you need or to make sure that you are ready to have the best camp experience possible. So now that we've talked about everything that we're going to need, and you know that you can pause the video if you need to go get any of those things, let's get ready to get started driving our Clawbot. So the first thing we're going to do is build one object, so this way we're all working with the very same thing as we learn about how to use the arm and the claw and control them with our controller. Okay. So all we're going to build is kind of a small open box. So this way we have something that we're all working with the same object as we're learning how to use our Clawbot. So what you're going to need to get out of your kit are 2 4x8 plates and 4 6-pitch standoffs. These are the longest standoffs that are in your kit. And if you're wondering where that 6-pitch number comes from, if you remember in a previous session, we talked about how each of the IQ pieces on the edge has segments that are called pitches. So if we line up our standoff with those segments, we can see that they line up pretty exactly, and we can count 1, 2, 3, 4, 5, 6 pitch, 6 standoff, 6 of the 8 pitches on our plate. So just a little fun fact for you. So all we're going to do to build this is we're going to stick each of these standoffs in the 4 corner holes of our plate. So we've got one there, one over here, another one on this corner, another one on this corner, and then we're going to take this plate and stick it on top. So you want to line it up so that each of those standoffs goes into each of the 4 corners. And now we have one open box that we can use in order to practice using our claw and the arm. So the reason we're doing this is so that this way everybody's got the same object that we know we can move really well, and then we'll go and explore some different objects that we can move with our Clawbot. So now that we have the object we're going to move, let's make sure that our Clawbot is ready to go. So before we start driving our Clawbot, there's a couple things we want to check and make sure we have. We want to make sure that our IQ battery is fully charged and inserted into our robot. So again, if it's not, you want to slide it into the brain and press it till you hear the click. There we go. And then we also want to make sure that our arm motor and our claw motor are plugged into the right ports, so that way they respond to the drive program in the way that we want them to. So we want to make sure that our claw motor, that wire comes back and is connected into port 4 in the front of our brain. And we want to make sure that the arm motor, that wire comes down and is connected into port 10 in the back of our brain. So if we've got those things connected, ports 1 and 6 should still be connected to your left and right motors from the BaseBot, just as they were before. Then we know that our Clawbot is ready to go, and we can press the check mark to turn on the brain. Next, we can get our controller ready. So here we can turn on our controller. Now your controller and your brain should remember each other. So you'll see that flashing green light if they do. If they do not and you need to relink them, you can just go into settings and repeat that link process that we did in the previous camp session. All right, so now we've got our robot ready, our controller ready, and we are ready to learn about how to use the arm and the claw to move our object that we built. Now on my table, I've put some tape down a couple feet away from each other to mark my sort of movement area. In your space, you're going to want to put a piece of tape or mark a string or just mark your area about 3 to 4 feet, just enough to give you some room to be able to drive your robot to move some objects. Now to start with, just to practice moving things, we don't have to move them very far. We're just going to focus on the arm and claw. But you will see those tape markers, and I wanted you to know what they were for. So now let's take a look at how we control the arm and the claw of our Clawbot. So I'm going to turn my Clawbot and set it up here with my little object right there, just so that way you can see things very, very clearly. So not only does our default drive program that we use to drive the BaseBot and drive and turn our drivetrain work for the BaseBot, it will also drive and turn our Clawbot. It will also control the arm and the claw. So when I start that drive program by pressing the check mark, and pressing the check mark again, I can use the same controls that I used in the previous session to drive my BaseBot, but now I can also use these front buttons to control the arm and the claw. So to start with, we're just going to start with the claw. The claw is controlled with the right 2 buttons. When I press the down button, my claw will open. When I press the top button, my claw will close. So you should follow along with me here and test out your claw the same way I'm testing out mine. So if we press the down button, our claw opens. If we press the top button, our claw closes. Now, what do you notice when you press and hold it versus just pressing it and letting it go? When we let it go, it doesn't quite stay in the same place, right? We can feel that there's not the same amount of tension there. So in order to grasp something, we have to press that button and hold it together. So now we're going to try a simple little thing to make sure we can use this claw to grab something and move it. So all we're going to do is set up our object that we built across from our Clawbot so that we can drive it forward together, hold that button, that bottom button to grab it. Sometimes I get them confused. You might too. Then we're going to turn our robot around. We're going to drive it forward a little bit. And now we're going to use that bottom button to open the claw all the way and then reverse our robot, and we've dropped off our object. Congratulations. There's your first use of the claw. So now we were able to use the claw to drag an object along the floor or the table. But what if we wanted to use the claw and lift the object up to move it, right? That will let us do things like stacking and lifting and grabbing things off of shelves and all sorts of fun stuff. So in order to do that, we're going to use the left 2 buttons on our controller. The up button by default will move the arm down. The down button by default will move the arm up. So we want to move it. Try that with me now. We're going to press the down button to move it up, the up button to move it down. If I press and hold it, it moves continuously and then it'll stay there. If I press it just gently or very short amount of time, we'll see that we can move the arm in different increments or different amounts. So now I'm going to put my arm all the way down to the bottom position, to its lowest form. I'm going to drive forward. You should drive forward with me. We're going to use the top R button, the R up button to grab our object. Then we're going to use the left down button to lift the arm. We're going to turn our robot around. We're going to drive it forward. Then we're going to use the L up button to lower the arm, let go of the object, and reverse to drop it on the other side. Congratulations! And that's how we can control the arm and the claw with our controller. Now you might be wondering, wait a minute, Audra, some of that we were moving down to go up and up to go down. It's a little confusing. Well, just like there are ways to use the controls or customize the controls to meet our driving needs, there's a little bit of customization that we can do to help us be able to move the arm and the claw in a way that works better for us. So we want to go back into the controls, just like you did to change the driver configuration. And I'm going to show you what that looks like on your brain screen. So now I'm going to navigate back over to controls, just like we did to change the settings on our driver configuration. So now here you can see the controls are left arcade because that's where I like it to be. Now if I move over, I can see that this is for port 10. Now port 10 is our arm motor. So that's showing that the left buttons that control the arm motor, they're currently set to forward. If we press the check mark and set them to reverse, it will reverse the orientation of the buttons. So now the left up button will move our arm up or raise it, and the left down button will lower the arm. I can do the same thing for port 4, which is the right buttons, which controls the claw motor. So if I press the check mark there, now my claw buttons will move in the opposite direction than they did before. So if you want to customize your controls on your robot, you can go into that controls and do the very same thing. So that's an option you have. It's not something that you have to do, but it's something that may make it a little bit easier for you as you're trying to drive and move objects really, really quickly, right? If we can move the up button to move the arm up, it might be a little bit easier for us to remember. So now that we tried to move one object, now we're going to think about how we can move two objects in relation to each other. So we're going to build ourselves a second little small object for practice, just like we did here. And then we're going to learn about how to use the arm and the claw motor to do a little bit more precision driving than what we just did. So let's build another small object. So we're going to build something just like this, but a little bit smaller. So for this object, you're going to need 2 4x4 plates and 4 4-pitch standoffs. So these are the second longest standoffs in your kit, and you can check that pitch measurement against your plates if you'd like. And we're going to construct this in the exact same way that we did our first one. We're going to stick those standoffs into the 4 corners of our plate. And then we are going to stick the second plate on top so that we now have a rectangular object and a smaller square object. So this is what they should look like when they are together, right? So now we now have 2 things that we can use with each other with our Clawbot. So the next challenge we're going to do is a little bit different. So now we're going to use our Clawbot to grab this smaller object, lift it up, and then we're going to try to drive it and place it to stack it on top of the larger one. You can try to also give yourself a challenge and stack the larger one on top of the smaller one. But to start with, we're going to go with smaller on top of larger because that just makes a little bit of an easier stack. So let's take a look at this object in relation to our Clawbot, right? When we had our big object, it was very easy to see that the claws went right in between, right? That worked. Now this object, you'll notice, is a bit shorter. It's just about the exact same height as our arms right here. So we're going to have to make sure that we're grabbing it a little bit more carefully, perhaps, or maybe we'll figure out a better way to adjust our arms to make moving it a little bit easier. So now we're going to start that drive program again. And now I have my customized arm and claw controls, so I'm going to drive forward. Okay, so now when we start our drive program, I can drive my robot forward. Now I'm going to use my claw buttons to grasp my small object. I'm going to raise it. Now I'm going to drive forward. And now I want to pay attention to where my objects are here so that when I lower my arm, it lowers and it lets it go right on top. Uh-oh, what happened? It fell off. Let's take a look at this a little bit differently. So now you can see that didn't quite work. So we're going to try it again, but this time we're going to move a little bit more slowly. So that way we can really pay attention to what's happening. So now I'm going to grasp that small object. Whoop, uh-oh. I grabbed it so hard, it flipped, right? Oh dear, look at this. This might be a bit of a challenge for us, but that's okay because that's part of the fun of using robots and driving robots is that it gives us a really fun challenge to try. So now each time we go to grasp it, we can think about how we're moving it. Now maybe I want to move it really carefully and slowly. Now when it comes to stacking this object, we want to pay attention to how the arm moves. Oh, what happened? Why did it come off? Well, let's take a look at how our arm moves when it moves all the way up. Now, I want you to look and watch where my arm is going. Is it going straight up and down, or is it kind of curving a little bit? So pay attention. When you move your arm, it goes up and it curves a little bit, right? And it goes down and it curves a little bit. So you can see that it makes a little bit of an arc as it's moving. So when we try to stack something, we have to think about that and think about how our arm is moving and where we need to place it. Because like right now, it looks like it's exactly lined up. But when I go to lower it, it might not be. So then I want to be very careful about how I move my claw and how I move my arm. So you're going to want to pay attention to that as you're trying to do things. And there we go. I got it to work. It did take me a few tries, and it probably is going to take you a few tries. But that's completely okay. That's the great part of playing with robots, right? This is what makes it fun. Now, if you want a bigger challenge, you can try to build another one of these and stack another one up there. See how tall you can make it go. See if you can stack these on the bookshelf in your house. So now that we've learned a little bit about how to use the arm, how to use the claw, how that arm moves when we're trying to lift and move things, now we're going to get ready for the relay race challenge. So we're going to do a very first little trial run so that you can get ready to make your Clawbot even cooler. So here's the part where we're going to use all of those household items that we talked about. So we're going to set up that space that we talked about, right? Having about 3 or 4 feet in between the starting line for our robot and the object line. So the goal here is that we're going to start our robot behind the starting line, and you want to time how long it takes you to drive across, grab all of the 6 items one at a time, drive them back, and drop them off behind the starting line. And the fastest time wins. So you're going to probably want to try this a few different times, right? Because we're not going to be the fastest we've ever been on our first try. So that's what we're going to do when you pause this video. So I'm going to show you how this works with one object. You can follow along with me if you want. And then you're going to pause the video and try to do all 6 objects for yourself. Okay? So here I'm going to start my drive program again. And now I'm going to try to drive forward in order to collect that soda can. So I'm going to drive forward. I'm going to get my claw around it. I'm going to grab it. I'm going to back up. I'm going to try just reversing backwards, leaving my robot there, backing up. And there we go. I got my first object already. So that's what you're going to do now. You're going to try to see how long it takes you to one object at a time move all 6 of your different objects. You can see here on my starting line, I use the 2 things that we practice with. I also have a baseball, I have a soda can, I have an empty cup, I've got an empty tissue box. You just want to make sure that you're not using anything that has any liquid in it or anything that's breakable, right? Because they might be fragile and we don't want to break something with our robot, and we certainly don't want any kind of liquids around our robot. So if you use a water bottle, make sure it's empty, or a soda can, make sure that it's empty. And if you're using a cup, make sure it's empty, and you might want to use one that's paper or plastic and probably not glass. All right, so now it's your job to go do the relay race challenge for your very first time, and then I will see you back here for some more camp fun later.
Welcome back. My name is Elena. Again, I'm one of your camp counselors, and you have just completed the relay race challenge. So how did it go? I know as I was trying to move things from one location to another, I had a few things or a few issues with my Clawbot. As I was trying to move the baseball, it was too short. So that's something I noticed, is that it was too short to get a grip on something like that, which made it a little difficult to grab. Also, as I was driving my robot from one side to another with the arm raised, it kept tipping forward if the object was too heavy. And then the last thing that I saw, that maybe you saw too, was that my arm was wiggling a lot as I was carrying those objects. So what we're going to talk about for this part of camp today is the ways that we can improve our Clawbot so that we can compete in the Relay Race Challenge and make our time even faster. So first, let's talk about how we can prevent our robot from tipping forward. If you remember all the way back to our Tallest Tower Challenge in session 1, we prevented tipping by increasing the size of our base. We were changing our center of gravity so our tower didn't tip over. And these are the same things that we can do with our robot now, is we can increase the size of the base of our robot, we can change our center of gravity, and we can create something that will stop the robot from tipping. So what I'm going to do first is I'm going to clean up my space, and then we can talk about how we're going to build our addition to our robot. So the first thing that I want to do is clean up my space, get my kits back out so we can start building an anti-tipper for our robot. Now this anti-tipper is just one example for what you can do to your robot. You can follow along with me, or you can gather your own ideas and build that anti-tipper too. So what I'm going to do to build my anti-tipper is I need pins. So let me grab those. I'll set that kit aside. I need 2 of my 2-pitch wide 3x2 corner connectors, which are these large ones here. So I'm going to grab 2 of those. I need 2 large chassis corner connectors, which are these ones here, those right angle. I need 2 of those. And then the last thing I need is a 4x8 plate. Now, if you remember, we actually used our plates as we were building our objects, kind of like this one here. I took that object apart, the one that used the plates, and put it back in my kit so I can actually use these 4x8 plates. So I'm going to grab one of these 4x8 plates, and then I can go ahead and put this kit aside as well. Now I'm going to be building my anti-tipper onto the front of the robot, because when the robot tips forward like this, it tends to stop tipping right as this front part, this front beam hits the ground. So what I'm going to do is use my plate to make it so it's always touching the ground. And then as the robot tips forward, the plate pushes into the ground and helps combat that tipping and that force trying to pull my arm and my robot down. So the first thing I'm going to do is actually attach these corner connectors in the middle here. Now, actually, let me put my robot like this. It makes it a little bit easier to see what I am building. I'm going to put this corner connector with the lip sticking outwards right here on this edge, and I'm going to do the same over here. So that's the 3rd hole in from each side. The next thing I want to do is connect my other corner connectors to these. Now, one thing that we want to make sure is that our corner connectors are positioned so we have some pins coming straight up out of the robot so it can attach to our plate here. So I'm going to grab my pins and I'm going to attach this to my robot. So I'm going to put 1 pin in each hole of my corner connector. And I'm going to attach this here on the front. It doesn't really matter whether the extra pins are going up or down, as long as you have them coming upwards to connect with this plate that's going to go on top. There are probably other corner connectors that you could use as well. This is just the one example that I have and that I was planning on using for my build here. So I'm going to attach the same way on the other side. So you can see here that corner connector is attached right there. And now I need to plan how I'm going to attach my plate. I want to make sure my plate is going to touch the ground. So it should be around the same height as the bottom of my wheels as I see here. And it should be roughly centered on the front. So I'm going to line up my holes and let's test and see if this is a good place for our anti-tipper. It may take a minute to get the holes aligned. Let me go ahead, look at it from the side. It looks pretty even. My wheels are still touching the ground, and I can hear that my plate is also touching the ground. I can't fit my finger underneath. So now let's test and see if this is going to tip over. Now that we've built our anti-tipper and attached it to our robot, we're going to practice picking up and moving something that's a little heavier that might weigh our robot forward and cause it to tip over. So what we're going to do for my heavy object, I actually took that baseball and put it right inside of this cup. You can use whatever kind of heavier object that you want. Just be careful that it's not too heavy for the robot and it could break something. So for this, I'm going to start my drive program. I have my controller. I'm going to open the claw, drive forward, maybe a little too far, close the claw, lift the arm, and now I'm going to drive around. And I can see my robot is not tipping over. So this is a great success for our robot. What I do see though is that my claw is barely able to hold on to this. And as I move, if you watch, that arm is shaking so much. So those are two more things we can fix. Before we do that though, I want to make sure that you get a chance to build your own anti-tipper. The next thing that you are going to do is pause the video and build your own anti-tipper. You can use any pieces that are left in the Vex IQ kit. Just make sure that it doesn't get in the way of the arm as it lowers or in the way of the claw because it's all right here in the front. So go ahead, pause, build your anti-tipper, test it out using a heavier object, and then come on back here once you have a successful anti-tipper. Congratulations! Now that you've built a successful anti-tipper on the front of your robot, we can start to work on one of the other issues that we saw to make our robot even better. One thing that I noticed that made me a little worried about our robot was how much it rotated as it was carrying the ball in the cup here. So what I want to do is add stability to the back of our robot. So this is our arm here, and this part of the arm is called the tower. Because the tower is the part that mostly was wiggling side to side, that's where I want to add our stability. If you remember back to session 1, we talked about stability with our tallest tower. And stability is the object's ability to resist some sort of bending or be able to go back to its original point instead of bending or twisting. So we can add stability by adding more connection points or by adding bracing, both of which we did back in the tallest tower. So we get to use all of those same skills we did back in session 1 in today's build for our Clawbot as well. So we're going to go over another example here for how we can modify our Clawbot and how we can add stability to the back of our Clawbot to this tower. Now, because most of the bending here comes from the middle or the bottom of the tower, that's where I really want to focus my bracing and my extra connection points. So what I want to do is use that extra 4x8 plate that we used for our object. We have one left, and I want to find a way to connect it here at the bottom so we can add bracing horizontal or perpendicular to our tower. So I want to add bracing here, but I also want this to connect to these pieces on the brain and the base of our robot. So it's connected both to the tower and to the base of our robot. So giving those extra connection points wherever possible. In order to build onto this and add that stability to the tower, I'm going to do my first section, which includes using a 4x8 plate, 2 2x6 beams, and some pins. This is going to be that main way that this is connected to the bottom here. So we're going to do some overlapping pieces, and I want this to be centered right here with overlap at the bottom with those extra pieces coming down. So I'm going to put my pins in. If you remember, we talked about the amount of connection points that you have and how that gives stability as well. So I'm going to fill in a bunch of these holes with pins just so we have that extra stability and those extra connection points. So I've got 4 for each one. I'm going to snap that on top. They're not in any particular order. I just wanted them to be on both the left and right side of each beam. So now these are firmly connected, and I can set this piece to the side while we work on our robot itself. So now what we need to do is add all of our extra connection bits to the back part of the robot. For that, we're going to use 2 more of those large chassis corner connectors. They should be the last 2 that you have in your kit if you've been following along with me. We also need 2 2-pitch standoffs. So I'm going to go ahead and look for those. I'm going to line them up to measure them. Now that's just a 1 pitch, so I know I need one longer than that. Sometimes if you need to, it's really helpful to pour them out into a plate. I believe this is a 2 pitch. Let me measure. 1, 2. So that's a 2 pitch, and that's a 2 pitch. And then I need 4 of those actually. So here are 2 more. And the reason I know that I need a 2-pitch standoff is because of where I'm going to place it. So I'm going to place these standoffs here coming out of these corner connectors to reach out to my 4x8 plate here and connect it. So I can look at this piece here and see 1, 2 pitch. So now I know my standoff needs to span 2 pitch. So I'm going to add those standoffs to each side. I'm adding them into the center holes of those corner connectors. I'm going to add these corner connectors right above that with the lip facing upwards into the tower itself. So this is how I'm going to connect the tower to my 4x8 plate. So I have the lip going up. I have one side going into my tower. It's in the holes just above this double wide corner connector. And the last thing I want to do is add some pins down here so that it can connect to the bottom of my 2x6 beams. So let me go ahead, add some of those in. The more connection points, the better. So if you have the pins, which you should, you can add them in and really make sure that this is a strong connection. So we'll add one in for each piece. And now we need to line these up and we're going to snap it all together. So I tend to start from one corner and then move across the top. And now I'm moving on to the standoffs to make sure those line up. And now I can move on to the pins on the bottom and snap those in. So it's nice to have some sort of system for how you're pushing everything together. The last thing that we're going to add, just to be extra sure that our connection points are strong, is 2 of our 0x3 connector pins. So we used these in the build for the arm. What these are, excuse me, let me find one. These are our 0x3 connector pins. So it is 3 holes wide, or it will go through 3 pieces of plastic or 3 connections, and it has a cap on the end. So this is our 0x3 connector pin. And because this is still lined up exactly with this corner connector here, I can actually line up and look through and find that right here, these holes in the center, if I push this all the way through, it's going to go through the 2x6, push it through once, it's now in the 2x6 and the 4x8. And if I push it one more time, it's also connected to this double wide corner connector that's inside. So now I have even more connection points between the two. So I'm going to grab another 0x3. And I'm going to put that in the center hole over here as well. So just every extra connection point will help give that extra stability, which is just like what we talked about in Tallest Tower. So now I have my extra stability on the back. If I start to try and wiggle this, it's much harder to move it. And now we can test it with our cup and ball. Now that we've added this extra stability to the tower of our robot arm, we can go ahead and test it out again the same way as we did before. So we have our drive program running. I'm going to open the claw, drive forward, close the claw, lift the arm, and turn. Now there's still a little bit of that wiggling, but it's not nearly as bad as it was before. So that might be something else that you can do, is you can follow my design, or you might be able to add more stability all the way up the back and add extra connection points. Maybe you want to add more pins in for those extra connection points. Those are just some of the possibilities for how you can add that extra stability for the tower of the arm. So now what you're going to do is you're going to pause the video. You're going to add stability to your arm. You're going to make modifications to your ClawBot in order to add that stability. Test it out using that same heavy object again, and come on back here once you have your stability modification added. Welcome back. Great job on adding that extra bit of stability to your robot arm. Now we're going to tackle our last problem for right now. We noticed, at least I've noticed, every time I've gone to pick up this cup, it twists down, and if I go to set it down, it won't set back down the way that I picked it up. My claw doesn't have enough places to grab an object for it to stay stable in the claw and fall. There's really only one connection point. If I look inside my claw, really the only part that's providing grip are these pieces on the inside of this corner connector. Now this is called your traction link piece, and it's a little rubber piece that helps to grab on or grasp objects. But it's so small. There's not very much area that our claw covers or can grip with. It's just these 2 holes right here. So what we're going to do is we're going to increase the grip area of our claw to hopefully grab objects like this better, and also help with things like this, which we built so that it doesn't slide onto the claw itself and make it much harder to let go of. For this example, for how to increase the grip area of the claw, I got out a few pieces already. What I grabbed are 2 more of the 2 pitch wide 3x2 corner connectors, 2 2x4 beams, 2 1x4 beams, pins, and more of those traction links that are in here. But there's only going to be 3 in this box because you get 5 total in the kit. So I'm actually going to remove one of these as well. So the first thing I'm going to do to make this addition is I'm going to take off these corner connectors, which this is a great spot for the pry part of our pin tool. So I'm going to pry that off, smoosh it in between, pry that off, move it to the side. Let me do the same to the other. And in this case, this whole beam came off, which is fine. I can snap that back in now that that's off. And then to take the traction link off of one of these, I can use the pusher right here and push on the opposite side. And it just pushes it right out of that piece. So I have my extra traction link. And then I have the 3 inside of this kit, which I can get now. So I have 1, 2, 3, and then my 4th one is in here somewhere. There we go, number 4. Then I can go ahead and put this jewel case away. In order to increase the grip area, we're going to be increasing down from this part of the claw. So I have my claw kind of at an angle. We're going to be going down from this 1x4 beam here. So what I'm going to do is I am going to place my corner connectors here with the lip facing outward. So I'm going to place it right on the ends where there's 2 holes still open in those beams. So now I have those connected here. And so now my claw is going further down, but I also want it to go further back as well so there's more connection points. So I'm going to use my pins, and I'm going to put pins in these top 3 holes here on each side. 2, 3. So just like this, let me show you a little closer. Just like that on each side. Let me go ahead and do that this way, just so you can see a little better. I know this is hard building with a fully built robot, but you want to make sure that you're trying to get the best angle you can so you don't accidentally break something. Now that I have those 3, I'm going to attach my 2x4 beam so that it's going long ways back. And I'm also going to take 2 pins and attach them right here at the bottom. And I'm going to put my 1x4 beam here at the bottom. So now I have this nice flat area open. But there's no connection on this back part, which seems a little dangerous or a little unstable. And there's no traction link, so there's none of that extra grip. So I'm going to put 1 traction link here in those holes that we left open on the 2x4. And I'm going to put 1 more vertically and connect the 2x4 and the 1x4 together here on the back. So now there's extra grip on my claw. We're going to do the same thing on the other side. So let me show you a different perspective. We'll go this way. I'm going to go ahead and put my 2x4 on. Use 2 more pins to attach my 1x4. Attach that there. And then I'm going to add my traction link, 1 in the center, right where there's a gap. And then 1 more connecting our 2x4 and our 1x4 together here in the back. So now I have a much larger area of my claw that should be able to grab. And what we can do, we're going to use our ball in our cup again, and we're going to test it out to see if it will pick it up straight and put it back down instead of it tilting to the side. Now for this test, we're going to do things a little differently than before. Rather than using the baseball inside of the cup, we're just going to test the baseball itself and also this piece that we built, because one of the issues was that the baseball was too short, and another issue was that this kept getting caught on the actual claw itself instead of getting moved. So now we're going to go ahead and run our drive program, and we're going to see, can we grasp the ball and can we grasp this without it going into the center? So first we're going to try and grasp the baseball. And now we actually can grab it and move it around without any issues. It's a little harder to lift up. We might need to add more grip to our arm if we wanted to do that. but we've successfully added extra area to our grip so that it can pick up something that's closer to the ground. Let me go ahead and put that back in the cup for safekeeping so it doesn't roll away. And we'll do our second test here, which is with this piece. Now with this test, we're going to drive forward. We're going to close the claw. We're going to lift this up. And now it's successfully staying outside of the middle of our cube that we built. So it's much easier to set back down and back off. Now that you've seen an example of how to modify the claw to increase the grip area of the claw, go ahead, pause the video, add your own things to the claw in order to increase that grip area, or you can follow along with my example if you want, and then come on back here after you've tested it out and know that it works. Congratulations! Now you've made 3 different sets of modifications to your ClawBot. We've gone through, we increased the area of the grip on our claw. We added stability to the tower of the arm by adding extra connection points and bracing. And we also added an anti-tipper on the front of our robot in order to prevent it from tipping over. Now that you've made all of these modifications that make your robot more effective, we're going to try the Relay Race Challenge again. This time you're going to try and improve your time and do it even faster now that you have these modifications. For the Relay Race Challenge, make sure you have 6 items. So right now we only have 5 here because we took apart one of the ones that we built. You can go ahead and find another object, build another one, whatever is best for you. Just make sure that you have 6 objects and that you have tape out a 3 to 4 foot area. Your ClawBot is going to start on one side of the tape, fully behind the line. You're going to drive your robot using your controller across. You're going to grab one object, bring it back and pull it across this start line. You're going to do that for all 6 objects and see just how fast you can go. Remember, if you need help timing, if you don't have a timer yourself, you can use the built-in drive program on the Brain, just like how you did in session 2. But you're going to use the time that's in the top left corner and can record your time that way. Congrats! You've completed the Relay Race Challenge, and I bet your robot was even faster at moving these objects than it was before. Or at the very least, it was more sturdy as it went around. Either way, you've improved your robot, you've made all of these modifications. You've also learned how to drive your robot using the controller to control the arm and the claw, and you're a great, successful driver with the ClawBot. Now in the next session, we're going to be putting our controllers aside to learn how to code our robot. So to prepare for our next session, session 4, you're going to take your battery out of your robot. Make sure you charge it just like you have between the past 2 sessions. Get that ready to go, and then come on back here for session 4 with your ClawBot and your charged battery, and be ready to go as we start to code our ClawBot.